Hey there, everyone. I'm delighted to have you here on my channel. In our last video, we began our JavaScript tutorial for the calculator, and today, we'll pick up where we left off. If you haven't seen the earlier video on this calculator project, you can find a link to the playlist in the description below. Let's take a look at the HTML, CSS, and JavaScript files we've designed in the earlier tutorial videos. The append to display function takes a value as an argument and adds it to the current content of the display section. For instance, if the display initially shows 5 and you use append to display 3, it will display 53. This function uses the concept of backspace. It first checks whether the length of the display's content is greater than 0, otherwise, it displays an error. If it is greater than 0, then the last character of the string is removed. This function clears the content from the display section by setting the display's content string empty, as shown here. This function clears the initial text or an error message from the display section. In the HTML file, the initial text of the display is set to made by Krisha. When this function is called, it clears this content from the display. Now, we will call this function when a button is clicked. 0, 1, point, 3, 6, times 9, divided by 2, plus 0. As you can see, the functions created are working as
1.
expected. Percentage. Delete. Delete. Clear. Delete. Nine. To validate user input, create a validate function as demonstrated below. The for loop iterates throughout the length of the display's content. It first determines if the first character is an operator. If so, an error message is shown, as the first character must be a number. When it comes to operators like plus, this is not the case. Here's an example to help us grasp this. Let's look at this case when the user enters plus 6 times 9. This is the same as 6 times 9, which is equal to 54. Now, when it is minus 6 times 9, this is equal to minus 54. Here, the first character is an operator, but still, the expression is valid. If the user inputs %6 times 9, the expression is invalid. On the other hand, if they enter 6% times 9, the equation is valid and equals 0.54. As we can see, the first character is valid when it is a number and invalid when it is an operator. Similarly, when a user enters times 6 plus 9, this is an invalid expression. Since multiplication or division occurs between two numbers, and for that the first character must be a number and not an operator. Else, when the first character is not any of the above operators, it checks for certain conditions to validate the user input. If the condition is satisfied, it is a valid expression, so do nothing, otherwise, display error. Add the following conditions inside the braces of the if statement. I will be explaining each of these conditions later. First condition is when a plus sign is followed by another plus sign. For example, 3 plus 4. When this condition is met, two plus signs are replaced with one plus sign and becomes 3 plus 4. This then becomes a valid expression. In the second, when a minus sign follows a plus sign, the signs are replaced with one minus sign. For example, 3 plus minus 4. When this condition is achieved, signs are replaced with one minus sign and become 3 minus 4. Similarly, when a plus sign follows a minus sign, the signs are replaced with one minus sign. For example, 3 minus plus 4. When this condition is achieved, signs are replaced with one minus sign and become 3 minus 4. Finally, when there are two plus signs, for example, 3 plus 4, the signs are replaced with one plus sign and become 3 plus 4. The conditions above are examples of valid input expressions using operators plus and minus. Next, conditions are for percentage operator followed by a plus or a minus operator. For example, 6% plus 3 is equal to 3.06 and 6% minus 3 is equal to negative 2.94. Next, conditions are for a multiply operator followed by a plus or a minus operator. For example, 6 times plus 3 becomes 6 times 3, which equals 24, and 6 times 3 is the same as 6 times negative 3, which equals negative 24. These expressions are valid. Then, a division operator followed by a plus or a minus operator. For example, 6 division plus 3 becomes 6 divided by 3, which equals 2, and 6 division minus 3 becomes 6 divided by negative 3, which equals negative 2. Now, we ensure that no two invalid operators other than the above valid operators exist consecutively. So, we check that any of the 5 operators are not repeated. For instance, a multiply operator should not be followed by a division. If these conditions are met, then an error message is displayed. Now, we create the calculate function to evaluate the input expression of the calculator. We use the try and catch block, where code inside the try block is executed, and the catch block is used for handling errors. Inside the try block, we first check that the display is not empty and then validate the input expression by calling the validate input function, as shown here. To evaluate this expression, we use the built-in eval function. This eval function does not recognize some symbols we used in this calculator, so we need to replace them using .replace, as shown here. Recall that we have an answer button that outputs the last answer. For evaluating purposes, this is replaced with the variable previous answer. Earlier, we had initialized the previous answer to error. Using the toFixed method, we round up the final answer to 6 decimal points, which is displayed and stored as the previous answer. When a user clicks the answer button, the stored result is displayed. I have added comments throughout his JavaScript file so you can read these comments for a better understanding. The last answer function displays the last answer when the answer button is clicked and calculates the expression with the answer using the previous answer. We have now created all required functions to evaluate the input expression. Now, we call these functions as demonstrated here. Here, we see that all the functions are working correctly,
Dark mode
and the
on.
calculator effectively handles error and
7
invalid input expressions.
times 9 equals to minus 3, 6 plus 2.15 equals to clear 6 percentage plus 3 equals to delete divided by times answer equals to light mode on, delete, clear, times plus 3 equals to minus 6 plus 5 equals to plus 8 divided by 9 equals to
We now create a function audio result that outputs the audio for the final answer in the display section. Firstly, convert the result obtained from the calculate function into a string. Iterate using a for loop and store each digit as a character. Then, initialize the audio file as shown here. Use the switch statement to select the corresponding audio file for each character. Append the audio file into the array of audio files using push. Create a play audio file function and call it inside the audio result function. This function ensures that the audio files are played sequentially and plays the next audio for the character only when the current audio ends. Also, do not forget to call the audio result function inside the calculate function we created earlier. Under the catch block, add the following code to output audio when the calculator displays an error message. Please ensure the corresponding audio file with the correct name is downloaded and saved in your work directory. Dark mode on. Light mode on.
Equals to 9 divided by times 3 equals to
Error. Please try again.
3 times 6 equals to 1. 8.
Neutral mode on.
Percentage minus answer equals to
Negative.
1. 7.8. 2. Delete. Clear. 3 divided by percentage 3 equals to
Error. Please try again.
clear. Percentage 3 equals 2.
Error. Please try again.
Minus 6 plus 6 equals 2.
0. We have completed the calculator project. Thank you for watching this tutorial, and if you liked this project and enjoyed this session, please like this video and share your views in the comments section.